General relativity explains that massive objects, like planets, stars, and black holes, warp the fabric of space and time, creating gravity. The core idea: time runs slower in stronger gravitational fields. The closer you are to the center of a massive body, where gravity is stronger, the slower time ticks. Real-world application: GPS satellites. Satellites orbiting Earth are further away from Earth's mass, meaning gravity is weaker up there, making their clocks tick slightly faster, by about 45 microseconds a day, than clocks on Earth's surface. Engineers must constantly adjust the satellite clocks for this effect. Otherwise, GPS navigation systems would drift by miles each day. Summary time dilation is a relativity concept that never took into consideration a zero-point low-density field. Thus, field allows for radical energy interaction with the field, but it doesn't cause warpage or dilation of different time on different planets or stars. Relativity puts a speed limit on all the universe. Radical Ha. The speed of light is a velocity, not a limit. Low-density zero-point fields allow energy strengths of infinite value. Clocks don't run slower as predicted by Einstein. The faster you travel, the less time it takes to reach destinations. That's all. Energy is not capped at c. Energy for thrust does not build mass. It builds speed. Whether you know it or not, energy doesn't contain weight, which is mass in relativity. So, E so MC2 is wrong. The quantum physics theory by Rodney Kawecki illustrates a E-MC2 equation, or the like of E-Xiao's MC2 equation for space and absence of mass in space equilibrium. It's orbital cycles that generate a massless weight. Speed. Faster. The idea of a zero-point field and vacuum energy is a fascinating area in quantum mechanics, where empty space is understood to be filled with fluctuating quantum fields rather than being truly empty. However, looking at how standard physics addresses these concepts highlights why mainstream science views things differently. 1. The speed of light as a limit. In special relativity, c is not just the speed of light, it is the fundamental speed limit for causality and the transmission of information and massive particles in our universe. Experimental evidence. Particle accelerators like the Large Hadron Collider regularly accelerate particles, like protons, to 99.9999999% the speed of light. As they approach c, pumping more energy into them increases their momentum and relativistic mass rather than increasing their speed, requiring infinite energy to reach or exceed c. 2. Time dilation is measurable, and real-time dilation is not merely an illusion of how long a trip takes. It affects physical processes at the atomic level. Atomic clocks. Extremely precise atomic clocks flown on airplanes or placed in orbit tick at measurably different rates than identical clocks on the ground. This matches Einstein's predictions precisely and is a required correction for technologies like GPS to function accurately. 3. Mass, energy, and MC2. In modern physics, mass and energy are two forms of the same underlying physical property, often described via the energy-momentum relation. When you heat an object or accelerate it, its total energy content increases, which, according to relativity, increases its resistance to acceleration, its inertia, mass. Energy does have a gravitational effect, because energy warps spacetime just as mass does. While alternative frameworks like Rodney Kawecki's quantum physics theory attempt to reinterpret space, vacuum equilibrium, and mass generation, mainstream physics relies on equations that have been rigorously tested and verified across countless experiments in astrophysics and particle physics. Slower time. Gravity. Stronger gravity. Slower time. Everyday reality. Time dilation is real and measurable, though the effects are microscopic at everyday speeds and low gravitational fields. That, of course, sit outside the planet observer at a distance, which means larger orbital cycle, meaning difference in Earth's original time cycle.
Here's a myth versus model you probably haven't heard. Myth: mass and energy are the same thing, and if I pour energy into a ship, it somehow gets heavier. Model, mass, and energy are different categories. Energy itself is weightless. Thrust uses energy to change velocity, not to add weight. The engine's weight is its manufactured mass, not the wattage it spits out. Myth: accelerate long enough and the ship gains weight just because it's moving. Model: acceleration doesn't bolt extra kilograms onto the hull. The payload stays the payload. Speed: direction, how I allocate energy for thrust. Myth: GPS proves big, dramatic time dilations everywhere. Model: GPS tick rates vary with distance and environment. How far the gadget is signal path spaces low-density medium, without needing to rebuild the clock's mechanisms. Tiny offsets exist, sure, but inertia and time dilations are microscopic, barely measurable for most practical use. Myth: space is a stretchy fabric that warps all over the place. Model: think expanse field, an ultra-low density zero-point backdrop. Vacuum as equilibrium, not elastic. Galaxies drift within it at the Hubble rate. The field sets the stage rather than bending under mass. Now take that perspective and push it. If space is a low-density zero-point field, then energy output isn't capped by a universal speed limit. The speed of light becomes a velocity, important, but not a hard wall. Acceleration isn't illegal, it's just engineering. How much energy I can feed into continuous thrust. That opens a door, faster than light travel as a model, not magic. Call it quantum physics theory, a futuristic space travel framework that treats acceleration as unlimited in principle, energy as weightless and purely kinetic in its role, the vacuum as a reverse pressure medium I can push against at scale. In this model, propulsion is simple: energy in, velocity out. No hidden mass gain, no penalty on the scale. The ship's mass is what it shipped with. The thrust is confirmed by energy flow, not by adding weight. And the math: if classic lessons say E/m/c2 links energy and mass, this alternative flips the sign to explore symmetry. E/m/c/2. It's a bold provocation, not a textbook rule, an invitation to test how negative correspondence might describe energy reservoirs, field balances, counter terms in a zero-point medium. Myth says, you can't go faster than light. Model says, speed is a state, not a ceiling. If energy and acceleration have no real limit, then velocity can be engineered, step by step, beyond familiar bounds. So what would travel look like? I keep thrusting as long as I can source and manage energy. I navigate the expanse field, treating space not as a barrier, but as a baseline. I correct timing by distance and density, not by bending time. And I size my engine for output, not for mass creation, because energy isn't mass. This isn't standard physics. It's a thought engine. A myth tests belief. A model tests reality. If quantum physics theory survives the math in the lab, faster than light stops being fiction, and starts being a roadmap. Question is, how far do I want to push the throttle?
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.